Now we are going to talk about object IDs and management information base. Let's talk first about the object ID tree. This is a visual representation of an actual database where this database is hierarchical. We can have parent nodes that hold child nodes, and we have a root node where all other nodes come from. It organizes objects where objects represent managed resources. For instance, one node may represent CPU usage, another may represent the host name of the device. Some nodes are read-only, for instance the CPU usage. Some other nodes are read and write, for instance the hostname. So every single remote device that we want to manage through Snmp will have one of these object ID trees living within the agent. Be aware that object IDs may be different. So this object ID tree may be different than this one and than this one. Every single node within the tree will get assigned a relative number and a name. So let's say that this particular node gets assigned the relative number of 1 and the name is directory. Every single node within the tree will also be uniquely identified by an object ID. In order to build the object ID, we need to enlist what are the nodes that we need to traverse from the root node to the particular node. So let's build this particular node object ID. It will be 1.3.6.1.1. If we wanted to use names, it will be iso.arc.dat.internet.directory. Most of the times we are going to work with object IDs that will start with the following sequence: 1, 3, 6, 1, 2, 1. If the object that we want to work with is offered particularly by Cisco, the sequence will start with 1, 3, 6, 1, 4, 1, 9. Working with object ID trees can become too complicated. In order to interpret them, we need some particular files that are known as message information bases, or MIBs, where these MIBs will help me to interpret a part of the tree. What are the nodes that exist there? What are the object IDs? How to work with them? In order to work with another part of the tree, we will need a different MIB. So we actually need several dozens of MIBs in order to work with a complete tree. These MIBs are text-based, human-readable, written in an extension to the language known as ASN1. They are key to understand and work with object ID trees, and they are usually installed at the network management system. Just a note here, the basis to have consistent telemetry data relies on the nodes retaining their object IDs always, even if the device gets restarted. Now let's talk about the interface index issue. The interface index is a unique identifying number associated with a physical or logical interface. So for instance, we have all Ethernet interfaces will start with 1 in this device, and all serial interfaces will start with 2, and so on. According to the original RFC 1213, this numbering will remain constant across device reboots. This behavior changed since the RFC 2863 was released, where indexes may change to accommodate the dynamic addition or removal of network interfaces. So we might have one device where its numbering for interfaces may be this, and after a reboot, this numbering can change. So this has a direct impact over the data that we have been gathering for telemetry, because it will make this data inconsistent. The solution is enabling a Cisco feature that is known as interface index persistence that will keep this numbering the same even if the device restarts. This feature is relying heavily on the interface description that exists within network modules. Just a final note here, be aware that field replaceable units such as fans or power units get a unique index number with this format after they are inserted. These entities will get assigned the next available number. This is a summary of what we saw in this session. We talked about object ID trees, we talked about object IDs, we talked about MIBs, and we talked about the interface index issue and the interface index persistent feature, and how field replaceable units get unique object IDs as well.